Good morning. We're going to go over functions and their properties. So basically, we're going to go over all the CLEP concepts. You take, take good notes, grab your notes, write the date, and we're going to go through every single concept that we need to know. This is a skill that is good for any subject at any time, which involves taking concepts piece by piece and mastering every one of them. So relations and functions. A function has a specific definition, which is more restrictive than what a relation is. A relation is simply a set of points. So if somebody were to write down 1 and 2, right, and 3 and 4, these are just relations. Like this, it could be anything for those values. Now, of course, every number on the left is in the x. That's your x representative, and then the number on the right is your y representative. So for relation, they can ask us in your book, they said for the relation, and then they gave you all these relations. List the set of ordered pairs for which the second member is greater than the first. So basically, if we're doing the same thing here, the second number is greater than the first. So that's how you describe that relation. So that would be one of the answers, and that would be the same. The second number is greater than the first, right? That's the first question or first thing they discuss. The idea is you just need to know that this one is the x value and this one is the y value. The domain of a function is represented by the x values of that function. So it's the set of first members of the relation. Even if a member is repeated, it is listed only once. The domain is tied to the x value and the range is tied to the y value. So we have domain and range. So x and y value for our domain and our range. So if somebody gives us a problem, like what is the domain and the range with these set of points, all we would say is the domain would be 2, 3, and 8, right? Those would be the values for the domain. And in math, you would notice us using something like that. So that's the domain. And the range would be numbers like 5, 7, and 9. That's the range. So the range is the y values, the domain is the x values. Those are the first set of items that they discuss in your book in chapter 4. So ordered pairs of points are illustrated on the Cartesian coordinate plane. Remember René Descartes, the French mathematician, that's who came up with this plane called the Cartesian plane. And so on the Cartesian plane, we can label those points on the Cartesian plane. If I have a point over there, and let's say this is 3 and this is 4, then that's just 3, 4. So on the Cartesian plane, the left number is the x, and the right number is the y value. Okay, so let's go ahead and graph a couple more points. This will be 2 and 5. We'll go up. You have 2 and 5 there. So that part of your book just goes over, labeling those points. Okay, let's take the first practical example here. What if we have to graph? Y is equal to 2x minus 2. Well, in math, we call this the slope-intercept form. So the slope is 2, and the y-intercept is negative 2. So we go to our graph. It's going to be linear, and so we go to the y-intercept, which is minus 2. The slope is 2. That means we go up 2 and over 2. So we go up 2. We go up 2 and over 1. Sorry, that's what I meant. Because the slope is 2, which is the same as 2 over 1. And we say rise over run. And so we go up 2 and over 1, up 2 and over 1, up 2 and over 1. So what are the steps for graphing? The first step is recognizing what is my slope and what is my y-intercept. We go to our graph, we put a dot or point at the y-intercept, which in this case is negative 2. It's called the y-intercept because at that point, x is 0, right? Another way of writing the y-intercept using the notation we talked about earlier is that the x value would be 0, the y value would be -2. So that's why that's called our y-intercept. That's where it intercepts the y-axis. So now we can connect these dots, right? And this is a sketch. So we'll connect the dots, and we have a line. The line has a slope of 2, so it's going to go up 2 over 1, right? It's going to rise 2. It's going to go over 1. It's going to rise 2, go over 1. So in order to graph a linear function like this, we have it in the slope-intercept form. We find what the slope is. We know what the y-intercept is. We plot a point at the y-intercept. We use the slope to find the next set of points, right? So number 1, identify slope and y-intercept. Number 2, use slope to plot points. Number 3, connect the points. This topic is discussed in more detail in Tyler Wallace, Algebra 2.1, 2.2, 2.3, 2.4, and 2.5. So let's say someone is watching this and they say to themselves, I'm not comfortable with graphing, I need more practice. Then I would recommend using Tyler Wallace Algebra to get this skill down. This is how we graph a line. We use the slope-intercept form of the equation of a line. It goes pretty smooth. The second way to graph a line is to use, so there's a second method which involves using a table of values. And this method works for any function, essentially. It doesn't matter what the function is. And the table of values is where you have x values, you're going to have y values. You choose the x values. But what I've noticed is so many times, especially with linear functions, first of all, you can choose however many values you want. But using from like -3 to 3 is a good, move. So then you take -3 and you substitute it back into the equation. So y is equal to 2 into -3 minus 2. And then whatever that answer is, you write it right there. So y is equal to 2 times -3, which is -6, minus 2, which would be -8. And then, so x is -3, I mean. So you plug it in and you get an answer. Then you do the same thing again. And then you do the same thing again. You do the same thing again. So you basically keep doing it for the equation of that line, and that's the value you get. So here's what's important as we wrap up this first segment of functions and introducing functions and their properties. It is important to know that in life, you will have options sometimes for what method should I use to solve a problem. And so engineers use this, entrepreneurs use this. This is a very good skill. I was meeting with an engineer yesterday and he was explaining just how the importance of learning how to just learn, right? And one of the things you realize is when you're faced with a problem sometimes, you might know one method, and if that method doesn't work, you have to learn that, you know what, I'm going to try another method. So one method that I've given you is just using the slope and the intercept. But what if you get to an exam and you're like, I've forgotten how to graph? Do you know the second method, right? So that's why we give you multiple methods. Because if you have multiple methods, then you can be more effective. So method 1 is just using the slope-intercept form. Method 2 is using the table of values. The table of values will always work for any function, period. It doesn't matter what that function is. If you have x values that you pick, you write down the function. Let's say it's y is equal to x squared. And then you substitute the values of the x values into that equation. That will give you the y values that you need. So that's how we graph equations of this kind. Let me know if you have questions. We'll come back and we'll move on to the next section of the video. Thank you.